Okay, now what do? We start with our equation. Okay, so I'm going to start with our equation over here. Dy over dx is equal to x squared y. All right, first thing I've got to do is what? Get rid of the dx. All right, so can I multiply both sides by dx? And the dx is cross out. Okay, and then my variables are not yet separated because I still got that y hanging out on the right-hand side. I can't have him there. So I'm going to divide both sides by y. So I'm going to divide by y, get rid of it over here. I'm going to remember that there's an imaginary 1 there that I'm dividing the y by. So I'm going to clean that up. So 1 over y dy is equal to an x squared dx. Okay, so far so good. Okay, now I'm going to integrate both sides because I've got my variables separated. So I'm going to integrate both sides. We ought to be able to integrate both of these actually kind of easy, right? 1 over y is going to be natural log absolute value y. Natural log absolute value y. All right, integrate x squared. That'll be 1/3 x cubed. And then we got to throw in the plus c. All right, so the integration actually was kind of easy on that one. Okay. Now we got to remember that this is logarithmic form and natural log has a base of e. So this is the new step where we rewrite into exponential form. So I'm going to do, and if you actually want to save the rearranging, you know it's going to be e raised to this equals that. If you want to just write the absolute value on the left-hand side because you know it's going to be there. All right, and then e raised to the 1/3 x to the third plus c. All right, so that's exponential form. After we did exponential form, we undone laws of exponents, right? So then this becomes absolute value of y equals e to the 1/3 x to the third times an e to the c. And then we got to tell somebody that we are going to let our e to the c equals k. That has to happen because you can't all of a sudden just randomly throw a k in the problem because they're going to look at you like you're crazy. Where'd the k come from? Okay. All right, then we'll come back up here. All right, now I can do absolute value of y is equal to, I'm going to put the k in front, k e raised to the 1/3 x to the third. I want to get rid of my absolute value bars. So when I get rid of the absolute value bars, I add a plus or minus e raised to the 1/3 x to the third. Okay. So what's that answer? General solution. Okay, now do I have some given constraints? I do. They told me that y sub 0 equals 2. So basically that's telling me what? X is 0, y is 2. That's giving me the ordered pair 0, 2. All right, so now I'm going to plug 0, 2 in. Okay, so I'm going to have 2 is equal to plus or minus a k, e raised to the 1/3, 0 to the third, which really doesn't matter, right? 0 to the third, 0 times 1/3 is 0. Anything raised to the 0 power is 1, so that pretty much just knocks that out, right? Which then means, now, is my k positive or is my k negative? I got a 2 right here, right? So I can just say k equals 2. It turned out that it's a positive 2. Okay, that's that plus or minus. It tells me, hey, when you find your k, it's either going to be positive or it's going to be negative. I got a 2 right there, so it's a positive. Okay, then what I'm going to do, I'm going to take that back and plug it back into my k. So then my particular solution is going to be a y equals a 2 e raised to the 1/3 x to the third. Right? Now I want to go one step farther. Okay. This is pretty yucky. This is pretty nasty, right? but I've got a base of an E, right? And it's raised to a bunch of junk over here, and it's multiplied by 2. But can't we see basically a y equals e to the x graph right there? I mean, yeah, you got a bunch of extra junk up here, so it's not a plain x, and you got a coefficient, but do we know what this graph looks like? Just a plain e to the x is just, whoo, just swoopy up, right? All right, I'm not going to actually take the time to make the slope field. All right, however, I will show you one that has already been made. All right, here is the slope field. Now, doesn't this kind of go up and to the right? So I've got that e to the x thing going. All right, now it has been shifted up to, which we really can't tell, but it's been shifted up to, and it's got a whoosh in the middle. That's very mathematical, by the way. All right, but do you see how this, had we taken this and done a slope field, this is what the slope field would have looked like. This is the particular solution. And we can at least, because what we know about our graphs, we know that that's pretty darn close.